in the UAE and in the Middle East. And I suppose as part of the infrastructure design team at CASDA, me and my team were responsible for the designs and the systems that we're implementing in our data centers.
Hi, morning all. My name is Joe. I work as a key account technical sales manager for the Stolz new Stolz team called MES COE, at the Center of Excellence that's based in Dubai. But Stolz, as an entity, we've been an entity that's been around for 75 years or so, and then from a cooling solutions point of view, we've been there for 50 to 60 years, 65 years or so, for critical cooling solutions, especially for the data center market. We're quite a global company. Our presence is quite global, not just in the Middle East. We are there in the Europe, the APACs, the Americas as well. And then we work with many of our customers like Costner as well, and lots of entities that we work with, or customers that we work with quite closely.
Well, thanks guys. So thanks everybody for joining. So if I go back a little while in my career, this is my 26th year in the data center sector. I know I don't look at it, but yeah, my 26th year. And around about 2010, 2011 was when I started to see the emergence of liquid cooling. We had worked with very interesting projects for the likes of the Met Office and the European weather stations, which had small corners of data center campuses dedicated to high performance computing and liquid cooling. And at my time going to see Hanover, for those of you who've been to CeBIT back in the day, almost over 15 years ago, the emergence of liquid cooling then, when I was able to see small memory chips and small glasses about the future. And kind of as I sit here today, we've evolved so much in that time scale in 15 years, and how we're really looking at mass adopting liquid cooling technology in the data center environment. So I'm going to start with Joe. And Joe's going to tell us a little bit about the product range that they have within Stolz that's helping to drive and help facilitate these demands.
Sure. So, like I was saying, so Stolz been doing cooling solutions for around 50, 60 years as such. And then we do cater for most of the thermal solutions from an air cooling point of view, whether it's cross, chill water solutions, DX solutions, chillers. We cater for all those. Even from a modular point of view, we look into that. But now the demand is looking more and more into higher AI and then higher density products. And then for that purpose, now we've got the CDUs from a direct-to-chip liquid cooling solutions, and we got one of the CMUs in the stand, customer stands here if you want to have a look. So that's what we have brought about from a direct-to-chip point of view. So basically, the way it works is it helps to take away the high amount of density cooling that is needed. At the same time, it helps to keep that differentiation between the chip side and also the facility side. So you get a more cleaner solution on the facility side. And at the same time, we can also have an high efficiency solution. Because right now we are talking about megawatts of capacities being taken off from a server rack. And instead of having a large number of fans and all to take away, to have that air cooling solution, now we are talking about smaller pumps, so the efficiency is now improving as well. And also you're looking from a facility side, if you're going at higher water temperatures, now we can look into more of dry coolers rather than chillers. Even from a Middle East point of view, if you can think about, because the chipsets are now running at higher temperatures, so which helps us to run the facility side also higher, which means that now we can look into dry cooler point of view, or adiabatic cooling as well, when it comes to even Middle East regions as well.
So really, really good point. So Kieran, coming to you, has CASDA been one of the prominent data center operators in the Middle East? Obviously, over my time in my career in Europe and in APAC, we've seen an emergence of mass growth in the data center footprint in those regions. Why the Middle East, from your perspective?
There's probably a number of reasons. I think power availability is definitely one aspect. When you look at data centers that need to be enabled for AI systems, you're talking about immense amounts of power. You're talking about megawatts in the vicinity, hundreds of megawatts. So that's definitely one factor.
No, good. And what's really driving the demand on CASDA to implement these sort of liquid cooling infrastructures across your portfolio?
So the biggest thing from my perspective is that in general chips are changing. So the amount of capacity or the thermal design power of CPUs and GPUs has increased really significantly over the last couple of years. 3 or 4 years ago, the highest CPU, like the top range CPU, was somewhere in the 150 to 200 watts of power. You now have CPUs that go up to 400 watts per hour in one single CPU. We have something very similar with GPUs, where 3 or 4 years ago your high-end GPU was 250 or 300 watts of power. You now have the likes of the NVIDIA H100, that's a 700 watt GPU. And I think a 1000 watt GPU is very much on their horizon, so it's only going to continue to increase. So that's really the driving force. You've got a lot more stuff in a really small footprint, a lot more power. So when you consider air as a cooling medium versus water is four times the specific heat capacity of air. So it's a lot more effective and efficient at delivering cooling than air. So in order for us to be able to serve and cool these extremely high-powered chips, liquid just becomes a kind of natural solution, a pretty good solution.
And then from the manufacturer's perspective, what innovation are you bringing to the table to help Casno with these types of solutions?
Yeah, so like Kieran was saying, so air becomes a bit of a concern when it comes to more than 50 kilowatt of capacity or 50 kilowatt of density per rack. We can still use air cooling. Nobody is saying that air cooling won't work, but it's just that we have to have more and more and more of cross, which means that more of a capex that is coming into the picture. So what you need to look at is more innovative solutions about how we can reduce the footprint of the cooling solution and at the same time make it more efficient as well. So yes, we're looking at different ways of the pumps that we select. Basically inside the CDUs, we have to make sure that the optimal pumps are selected so it runs at the optimal conditions, so the power that is taken by the pumps is lower. So the kilowatt per footprint from a power point of view actually reduces as well. So that helps in the efficiency point of view as well. Now from a data center point of view, if you look from an operation side, so they want to make it as simple as possible. So the way we design stuff is we want to make it not just the efficiency point of view, it's about scalability and how to make it, how quickly can deploy into the site as well. So we're looking at different innovations in that point of view. So we come up with skid solutions where you have the rack mounting and the skid mounting, the rack manifolds and the row manifolds already built in. So which means that it's just a plug and play solution. You drop it into site, plug it into it.
So you're not looking at this just from a new build perspective, but also retrofitting into existing facilities.
Exactly.
So you have specialist solutions that cater for that. And then probably two questions. How do you guys as the supplier deal with it? But then from a data center operational side, how do you guys implement it and integrate it into an existing facility, for example?
So if you, for example, for the new builds, yes, you got the CMUs, and then you can have these skid solutions or an integrated liquid cooling solution, we kind of call it, where everything is built in. We can get that straight away on the site for a new build. But if you're talking about integrating for something an existing site, and you want to start seeing whether that's how can we deploy liquid cooling from initial point of view, there are even single rack solutions like we got the micro DC which have liquid cooling built in as well. So if you want to try that out, so yes, there you go. You can have 100 kilowatt per rack liquid cooled solutions built in as well. So these are the kind of innovations that we bring in from a Stoll's point of view. And we work mostly from a customization point. So if you have a standard CDU, for example, and then we're talking about approach temperatures, where basically the technology side temperature and the facility side needs to be closer, which means that we can increase the free cooling side. So these are the all customizations that we can bring in from Stoll's from a plate heat exchanger selection point of view as well, which helps on the PUE side for the data centers as well.
Absolutely, yeah. That's one thing I did want to touch on when we talk about liquid cooling and delivering cooling via water more effectively and efficiently. It allows us to potentially increase our operating temperatures of data centers. So that means that if you increase your operating temperatures, you can operate at a much lower PUE. Now, if we consider a data center in Dublin versus Dubai, you already have a pretty good PUE if you're in, Western Europe and cooler climate, somewhere like the 1.2 average annualized region. If you're able to increase your chilled water temperatures, you are going to obviously get a benefit in terms of PUE, but you already have 1.2. You're going to come down to maybe 1.1.
Sorry, we lost the...
Can you still hear Kieran?
We can hear
You can hear it.
Okay.
That's what we don't need to hear.
So the 1.2
The potential benefit in hotter climates like Dubai and the Middle East, the potential benefit there in terms of PUE for higher operating temperatures is going to be a lot more, you're going to feel it a lot more in terms of PUE. Your PUE can come from, the 1.4, 1.5 average annualized down to maybe the 1.3 range. I think the benefits from the increase in operating temperatures for data centers here are going to be a lot more impactful than your existing data center hubs like Western.
So
so we've touched a bit there about the efficiencies you're seeing, the ability to give you some flexibility of what's happening air and liquid. But what's really driving this change in your portfolio of sites for liquid cooling? Who's driving it and what's driving it?
So, yeah, like I mentioned, the real driver is these new kind of generation of chips, right? They need liquid cooling, and when you look at the hyperscalers who want to deploy AI-ready systems, they need those high-power chips in order to drive their large language models, or whatever AI applications they're driving. So that's really the drive. As we move into a generation where AI becomes more mainstream, and you have the large hyperscale customers wanting to develop AI, liquid cooling, because it's associated with those high-power GPUs, is the way to do it.
And just looking maybe a little bit further ahead, obviously knowing the data center is pretty risk adverse. You know, changing even types of cooling methodologies, maybe from air cooled to indirect to direct, having this big change to liquid cooling. What's next in the future for Stools?
So liquid cooling is going to evolve for sure. I mean, every era we've seen a change in cooling technologies. It was initially cracks and then cross, and now we're seeing liquid cooling now. Now that's going to evolve for some time. And we're going to enter for immersion cooling, so because the amount of CPUs and GPU power that's increasing, it's increasing tremendously. And there's going to be a time when you'll say, oh, that's a direct-to-chip can't sustain anymore. Like air cooling can't sustain anymore. It's a sustenance temperature of the silicon that we're talking about. So there's going to be a time where we have to look into immersion cooling as well. So we are ready from that point of view, from a solution point, but it's about when the end users and when the data centers are ready to take it up as an in-cooling solution. Yeah, that's where we see at the moment, but we can't predict what's going to happen in the future. Future is always a prediction, isn't it? So
maybe a little bit of a challenging question, but we spoke about it from an innovation perspective. Kieran spoke about it in terms of what's driving it, and that's the type of NVIDIA or GPU technology that's being used. But what more holistically is driving that demand for this mass compute power? Just your own impressions really from being in the sector.
I think it's a drive to AI, so everything is becoming automated, and we just show an innovation there. You ask a question to a robot and it just gives you an answer. And then we are all going to see that happening. Everything is becoming digitalized. Maybe next time we won't be sitting in person, we'll be in 3 different locations, and our robot images coming here and speaking to the rest of the people. So that's what's driving everything. Everything is data crunching and data analytics, and how quickly you can go to market, how quickly you can respond. So
I caught my 9-year-old doing his geography homework using ChatGPT. So I was quite disappointed in that, because certainly might not know how to write or is. So outside of that, what other, obviously we're within the data center sector, we're within the technology industry. How do you see AI impacting and really the data center sector becoming the backbone to infrastructure for other industries? What other industries are really driving?
I think we are kind of like the F1 of motorsport. So we bring in the new technologies which gets implemented into the rest of the industries. So if you take about healthcare, and that's one sector where you don't need doctors in person to do an operation anymore. Then you got what do you call it, stock markets. So all these are industries where it's basically finance operations. So all these are industries where innovations have been happening quite quickly, and that's where the latency is a point. So that usually why data centers come very close to where the switch points are. So all these comes into the picture as well. So yeah, that in other industries also will be coming.
I wonder how much AI power was used to land the rocket and catch it. Did everybody see that?
Yeah.
Absolutely insane. Okay, so changing gear a little bit then. So back to Kasna. So you guys have positioned yourself as one of the leaders in the region and globally about adopting this cutting-edge technology such as liquid cooling. How is it? How could you share a little bit more about the challenges that you're facing around sort of the adoption of this technology on a large scale?
Yeah, I suppose like the point that you touched on, data centers are built around redundancy and resiliency and high uptime. So adapting to change can often be, a little bit challenging, especially when you need to do it in a way that ensures you're maintaining uptime and you're reducing any risk to the data center. So that's probably one of them, trying to adapt to change. It's inherently a little bit difficult to think you've got IT electrical equipment and you're bringing liquid water directly to it. So there's definitely challenges there in terms of deploying the systems. I think from an operational perspective, it's something we have to be very, very careful of how we're going to operate expensive pieces of equipment. So the water quality and maintaining that water quality in your technology cooling loop that goes to the CPU is extremely important.
It's very different as well.
It's very, very different.
Management of it as well, the design of it, everything is different.
The filtration levels, the water quality levels, that will have to be maintained, observed, and monitored really, really closely just because of the equipment you're dealing with, how expensive and important it is to our customers and their operations.
And what just for both of you really, a lot of the topics, in my role, from a design perspective, is all about speed, time to market,
Yep.
who can get it. Because obviously, this is a global revolution, should we say, in terms of AI deployment. How really are supply chain able to keep up with that? And then secondly, how are you as data center operators manage to deliver that for clients? So we'll do Joe
Right.
first on the supply chain globally and keeping up with the speed of deployment.
Yeah, so right now the demand is going to be very high with plate heat exchangers and pumps. So who was having a plate heat exchanger and pump company? Yeah, good for you guys. So the demand is going to increase tremendously. But yeah, so we are preparing ourselves to gear for this. So the uptake is quite high. So whether we taking from a hyperscales point of view or from a colo point of view, it's constant. All the designs which you are aware of as well, it's been changing to a combination of liquid and air cooled. So we have to be prepared for it. So we are, all our plant room, all factories, everything is getting prepared or geared up to make sure that we can take up this high demand. So we are not looking at huge lead times in the sense we're talking about the same, similar to cross, like 13, 14 weeks of lead times that we're looking at from a CDU point of view. And that's going to improve constantly because even the suppliers are going to understand the demand's going to come up. So that's why we're seeing. So
Yeah, and obviously that's at the vendor level where multiple manufacturers across the globe all working together in the sector.
Yeah.
But hearing from your perspective as a data center operator, obviously you're talking 17 weeks, you might be talking 17 months or less.
Hopefully less, yeah.
So what's driving that from your perspective? How are you overcoming some of those challenges?
The drive from it is customer demand, right? There's so much customer demand for AI systems and data centers right now that it's delivered as fast as you can, which is obviously challenging. A data center, especially a hyperscale data center, such a large, complex project that trying to put all of those pieces together as fast as possible is difficult to do. But I think obviously we would work with suppliers like Stutz and designers like Red in order to design facilities that we can build and deploy our systems as fast as possible. Things like DMFA, off-site fabrication, so you can bring equipment, whether it's cooling equipment or modules that have pipes and cables to site ready to install, that they can just be plugged in. That really, really speeds things up. So we try to adopt that in our, I suppose, our construction approach, and even when we're looking at our system designs, we think about it from a speed to deployment perspective.
I think that's where the skid solutions comes into play as well, like I mentioned. So we can bring the whole package straight away onto their site and it's just plug and play. So it's like CDU, the racks, all you have to need the servers then, so you get all the manifolds, everything built in, so that makes it quicker
more
as
of
well.
a sort of integrated, collaborative approach to delivering.
Absolutely.
Exactly, yeah.
Cool. Okay, so what about challenges? What's the biggest challenges you kind of face at the moment in both sides of the table?
So first and foremost is, again, we're now talking about, rather than going from efficiency, we are now talking about efficiency from a chip point of view. So instead of seeing
maintaining the efficiency as well.
Exactly. So instead of the water temperatures going higher, now we are talking about water temperatures going lower, which means that okay, now we have to change the entire design philosophy of a CMU. So you're talking about temperatures at 20, 25, and all, which means that you're now going back into chiller. Okay, it's fine, we can do it because this helps us in the sense we can sell more chillers. But then where do you talk about it from a PUE point of view when it comes to data centers? And that becomes a challenge for them. And also becomes a challenge for a supplier point of view because now we have to look into plate heat exchangers with closer approach temperatures, make it more and more efficient. So that is definitely a challenge, and how you packet everything into a CDU, and then again when it comes to data centers, for customers' point of view as well, or any data centers point of view. If you need multiple CDUs because the approach temperatures are coming closer, where do you get the footprint for it? The white space, do you have to encroach into the white space? No, we don't want to do that. Or even the cooling corridor, if you put more. So these are all the design challenges, but I think what's going to happen is once we have that couple of designs catered down, or a couple of installations completed, and then it becomes like a standard norm, and it becomes as simple as a CRA or a chiller or chill water installation.
So we move kind of out of the early adopter phase into the mass deployment phase.
Exactly.
We're a Casna in the whole scheme of things? Are you early adopting or are you en masse?
I'd like to think we're early adopters, yeah. You kind of have to be, right? So we're designing and building facilities that are going to be operational for 15, 20 plus years. Whatever we're designing and building now needs to be suitable, or at least have the flexibility to not deal with what the challenges are today, but to deal with what the challenges are going to be in the future as well. So when we're looking in systems, when we're designing systems, that's something that's at the forefront of our minds, what we're doing. And it has to be, right? I think, like you mentioned, one of the other biggest challenges for data centers as a sector has to be sustainability. I think today data centers are about 2% of global power. That's soon to increase to 4% with the advent of AI. We have to build and operate data centers in a more sustainable way in order to meet any sort of climate goals.
And give us a bit of an insight. So what are you guys doing on the operational side from an efficiency perspective? How are you balancing that power consumption or forecasting power consumption with remaining sustainable?
Yeah, so you kind of touched on it there, right? It's operating your systems at the most efficient way. So you're running equipment only when it's needed to provide the cooling and power that's needed. You're operating your cooling and power systems that you're delivering the cooling and power more efficiently. And look, that not only makes sense from a sustainability perspective, but if you're looking at your CapEx and OpEx, or your OpEx I should say, that makes more sense, right? If we can operate a data center at a lower PUE, it's more cost effective for us and our clients.
And it sounds there that there's no kind of silver bullet for sustainability. It's a complex mechanism of multi-different components that allows you to remain efficient.
I think it has to be. The technology is going to be a part of that, right? If we can adopt the latest technology and the most efficient, whether it's cooling units or chillers or systems that are designed that will allow us to operate more efficiently, be more sustainable, and meet our
And will you guys be using AI yourselves, maybe in helping with the operational sustainability of your facilities?
You kind of have to, right?
Yeah.
Practice what you preach.
And then from an evolution of manufacturing or design, are you guys?
So definitely, we'll have to look into the same analytics point of view about how to improve your manufacturing process and what can be made different as well. And also, something touching into renewable point. I mean, I like the way they've adopted solar power as a renewable source, and then now we are talking about nuclear as an
Lots of
adoption.
different sources. We do a lot of work in the SMR sector.
Yeah.
But we've got like 5 minutes, so we're going to open it up to the floor. Do you want to take some challenging questions from these guys? We see some familiar faces. Anybody got questions for the Stokes team or for Asma or for Red?
I have one question. On the liquid cooling to the immersion cooling, how do you see like the advantages of the immersion cooling?
So good question for those who didn't hear. It was a combination of the differences between liquid direct to chip and then also immersion.
Yeah.
So how do you guys both see that?
So from an efficiency point of view, if you based on the amount of heat load that you need to take away, always immersion is going to give you the additional tick mark. When it comes to that, yes, you can take up heat based on efficiency. When it comes to the capex at the moment, that's where the immersion now becomes a bit of a challenge at the moment. And that's
On the
I
chiller,
would also add that from a design perspective and from a management and from an operation perspective, that's maybe why we've not seen the emergence of the immersion, a more uptake of the immersion. It's still being done on a small scale. Sorry, Kieran, from your perspective, immersion versus liquid, direct to rack or direct to chip?
Yeah, a lot of it from our perspective, it's a data center operator is driven by the likes of NVIDIA and these guys. If they're deploying their latest GPUs or their latest CPUs with direct to liquid technology, that's something that we're going to adopt in our data centers because that's something that our clients will look to deploy themselves. If you get those big guys kind of more openly adopting immersion cooling, it might force us to change our way of thinking.
So the liquid to rack is driven by the type of technology that we're implementing and deploying in large spaces.
There's also the question of what is the guarantee that you get from the server manufacturers when it comes to immersion. So if you have the guarantee, then the exactly. Exactly, and also from a data center operations point of view, it's the entire cost changes. So yeah, the operations systems changes, how you do the maintenance. All these are changing when it comes to immersion cooling compared to that. That actually could be similar to a cryo unit.
We were kind of looking at making technical corridors, service corridors, and then we're actually putting that back into the white space with immersion. Operational headache then.
Exactly.
Anyone else have questions? that?
We've done a good job.
Yes, yeah.
Too early?
Should be.
Any closing thoughts?
No, I think from right now we're seeing an adoption for when it comes to AI and high density, we're looking at direct to chip at the moment, but that's not saying that direct to chip is the final when it comes to technologies for liquid cooling. Yes, immersion will come into the picture, but somewhere down the line where everyone starts to adopt it, the maintenance, the service, everything is adopted, or the warranty also comes into the picture. But whichever way it is, we as Stoles, we are prepared for any kind of cooling solutions, and we look into the future as well, what is there, what's the new that's coming in, and we look quite ahead as well about what can be done as well. And like I said, ours is mostly, we try to work into more of how we can sustain efficiency, scalability, and these are the kind of factors that we look into, and customization as well.
Which is a change because we're now doing it at a much bigger scale.
Exactly, exactly.
And Kieran, any closing sort of thoughts from you on this revolution that we're seeing?
I think everyone is having